Hi, I'm Radu Ionescu and today I'm going to present detecting abnormal events in video using Narrowed Normality Clusters. This is joint work with Sorina Smeureanu, Marius Popescu and Bogdan Alexe from the University of Bucharest and Securify. Abnormal event detection in video is a challenging task because abnormal events are rare and depend on the context. Here is an example with a person running in a sports arena, which is normal, and a person running outside the bank, which is abnormal. Since abnormal events are scarce and hard to collect, supervised methods are generally ruled out. Therefore, models are usually trained on normal events. Our first contribution is a two-stage outlier elimination approach based on k-means and multiple one-class SVMs. Our second contribution is to augment the spatial temporal cubes with location, motion direction, and deep appearance features. This figure illustrates our pipeline. During training, we apply a two-stage outlier detection algorithm based on k-means and one-class SVM. We eliminate the smaller k-means clusters as outliers, and for each remaining cluster, we shrink the borders using one-class SVM. During inference, we label a test sample as abnormal if its maximum normality score among the scores provided by the trained one-class SVM models is negative. We motivate our assumption that the smaller k-means clusters contain outlier samples through a toy example. Here we have a set of 400 data points sampled from two normal distributions of different means. The points are clustered into 30 clusters using k-means. The centroids of clusters with less than 10 samples are represented with a large blue square. These get eliminated in our approach. We compare our approach with several state-of-the-art methods on three datasets: Avenue, Subway, and UMN. As evaluation metrics, we employ the area under the row curve computed with respect to ground truth frame level annotations and, when available, ground truth pixel level annotations. On the Avenue dataset, we also show some ablation results. We can see that both k-means and one-class SVM play important roles in obtaining improved performance. Overall, our method attains the best performance. In this figure, we illustrate the frame level anomaly scores on test video 4 from Avenue in blue against the ground truth labels in pink. A threshold of 0.5 is set in order to determine which frames are abnormal. In this figure, we show true positive detections on the top row and false positive detections on the bottom row. Abnormal events are people running or throwing objects. In this video, we show an example of abnormal event localization. And these are the results on Subway dataset. We notice that our method surpasses the other methods by a large margin. In this figure, we show true positive detections on the top row and false positive detections on the bottom row. True positive detections are people walking in the wrong direction or people jumping over the gates. False positive detections are people walking synchronously. And finally, these are the results on the UMN dataset, which seems to be the least challenging one. Our approach attains a frame level AUC of over 99%. In this figure, we illustrate the frame level anomaly scores on scene 3 from UMN in blue, against the ground truth labels in pink. Once again, we set a threshold of 0.5 to single out abnormal frames. In this figure, we show true positive detections from UMN on the top row and false positive detections on the bottom row. True positive detections are people running in all directions. Thank you, and please come to see our poster.